we're going to look at some volumes, and I'm going to basically just kind of write down some volume formulas. I think they're more fun to derive, but that, I would say, for a geometry class. And these are things we tend to use. And so we saw that volume, when I was talking about unit conversions, was a length times width times height, which means for a cube, the volume is the sides cubed. If I have some, let me see if I can. So if I have some cube, then all the sides are the same, and so length times width times height would be that side cubed. Now there's some interesting shapes that have interesting volumes. Interesting shapes with interesting volumes. Well, we'd hope so. We'd hope the interest would come through. And so a pyramid which has a square base, but let's make a pyramid with any base, but we're going to look at a square base. So let me make a kind of square base pyramid. I have to get my dimensions right here. And then this comes up to a point. This comes up to that point. And that comes up to this point. And so there's a pyramid. Right. And there's some height to it. If I take from the point straight down, I'm able to get the height of the pyramid. And this base, we can calculate the area. So in this case, it's square. But if it was another shape, then we could calculate from there. And so pyramid is a structure that will have a rectangular base, and then in some triangular sides that come to a point. You can also have a triangular pyramid, and this same thing will work out as long as you have triangular sides that come together for a point to work it out. And so the volume of a pyramid is 1/3 the area of the base times the height. So in this case, this is going to be a length and a width. And so we would get 1/3 length times width times height, right, if it was a rectangle. But we encapsulate the area of the base like this. And what happens is a pyramid, volumes tend to be, if I'm stacking cubes, these cubes go down by 1/3 due to the angle coming here. So, again, these are fun to derive. They're kind of memorization otherwise. And so, unfortunately, memorization is not the part of mathematics I like. Pardon me. But I'm going to give you some of the basic formulas here. And then we can build them off. All right, there's a thing called a right cylinder, or as I like to call it, a soup can. And so it's a cylinder at right angles, which mine's a little slanted, but everything's at a right angle. The sides are straight. There's two equal circles at either end. And so the volume of this cylinder is, well, I take the area of the circle and I multiply it by the height. But the area of the circle is going to be pi r squared. And so we get pi r squared times h gives me the volume. Now, this gives me a kind of a neat kind of parallel is I can take a pyramid concept, but I can make it circular. So I can take a circular base, and I can make each side come to a point. Well, that's a cone. And so a cone, well, yeah, 1/3 base times height. The volume is 1/3 base times height, but the base is a circle, so it's 1/3 pi r squared times height. So there's a fundamental rule that's kind of building these things, and it's probably the biggest joy of calculus, is finding what that rule is. I mean, if calculus were to have a joy, it's like peering into the secrets of the universe. It's not really the calculation part. It's the finding the rules that link these, and we can kind of see them. They're hinted here, right? 1/3 base times height makes a pyramid. Well, cone's pyramid-like, and look, 1/3 base times height is popping out of there. So there's some underlying principle that's making this and spitting out the thirds and doing the things there. And then a sphere. So a sphere, the best way I can do a sphere is take a ball and put another circle in it, right? And so I have a sphere, three-dimensional circle. So it has some radius from the center, and if I were to spin that around in 3 dimensions, well, that volume is 4/3 pi r cubed. And so that's the volume of a sphere. And so this is the volume of our common objects, which is useful for us. There's another thing that comes out of these. These things have surface areas. If I were to paint the object, so if I were to go to paint a cube, I'd have to paint that side, I'd have to paint that side, and, well, a cube has 6 sides. And so we're going to say the surface area of a cube, well, each side is s squared, so it's 6 s squared. So I'll paint each side. And if it's a rectangular solid, if it's just a rectangular solid, then I have to calculate the area of each side. So if I have just a rectangle, and I turn that into a solid object, there's still 6 sides, but these two are the same. So I have 2, let me make this my length, make that my width, and I'll make going up here my height. So this side is the height times the width. So I have 2 times the width times the height, gives me this side and this side, plus, well, I get 2 of these opposite sides, and that's the length times the height. And then I have the bottom and the top to do, which is the 2 times length times width. And so the surface area of a rectangle, which would have been the length times width times height, I get 2 times the width times height plus 2 times the length times height plus 2 times the length times width. That's a lot to say. But it would paint that. And so what I'm doing right now is I'm looking at the surface areas. Well, the surface area of a cylinder, I have a circle on top and a circle on bottom, so I have 2 times pi r squared. That gets me the top and the bottom. And then if I were to unroll the circumference, I'd get a rectangle with the circumference as its length. If I were to think about rolling toilet paper or paper towels, right? And you were to do one circle, that top length would end up being the circumference, and it would make a rectangle. And so the circumference was 2 pi r times h, and that gives us the surface area. That's a plus here. So we get 2 pi r squared plus 2 pi r h gives me the surface area of a cylinder. Right? I always thought cylinders of soup tins, because back in school we had to collect the soup labels, and so to get the surface area for that. And the surface area of a sphere, for the pyramids you have to add up the triangles in the base. Cones are complicated, we'll save those for later discussions. But a surface area of a sphere is 4 pi r squared. And so now we can paint all of our surfaces and know how much paint we have. I really like the colors on this screen. It's my like late 80s throwback. Alright, work through the problems. The problems will be finding the numbers to plug into these things. If you have any questions, send me the link in Pearson and I'll try to make a video on it. Also email me if you have any questions. I've been getting some email and responding to them. And if you just try to reach out if you need anything.